Hello. Hello. You can see green color. Okay.
Audio setting, huh? Headphone.
Huh?
Headphone.
No, headphone is set already. You can mute this one. Yeah.
Hello. Am I audible? Am I audible?
Yes, sir.
Okay. Yeah. Yes. So, good morning, everybody. I'm profoundly delighted to take an opportunity to welcome you all for this program. It's a glorious moment to extend my warm wishes on behalf of the Department of Civil Engineering, Ramaiah Institute of Technology, Bangalore. It's an opportune moment to refurbish and debate upon the problems of mutual interest with our esteemed delegates from the industry as well as the academics. The seminar schedule brushes upon a spectrum of exciting and benefiting themes that discuss the aspects of advances in highway technology and traffic, as well as the transportation problems. I bid a very warm welcome. I bid a very warm welcome to all the renowned speakers, delegates, participants who took out their valuable time and joined us today to be a part of this conference. We are honored to have you all with us. I would also like to offer my regards to all the people who made this seminar functional in such hard times. The theme of the conference is based on the global problems, research, and their solutions, and thus the advancements which would hugely help the faculties, the stakeholders, as well as the participants in inducing a thought for the problems which the world is sustaining. Before we carry on with the events, I would give my regards and appreciation to all the people who made this occasion a reality and this faculty development program successful. This could not have been possible without the sheer contribution of you all. We all are a part of this institution due to our shared passion for the vision of the institution. Our passion unites us and our hard work strengthens the institution. On that note, I would like to call upon and welcome our beloved Head of the Department, Dr. M.C. Nataraj, Professor, Department of Civil Engineering, to brief about the department and the institution. So without any further delay, I would like to start with the events. We would be delighted to have your suggestions and questions at the end of the event. Enjoy the event. I welcome you, sir.
Thank you very much, Professor Niranjan. I'm extremely happy to be a part of this wonderful program, the faculty development program being organized by the Department of Civil Engineering. At the outset, I welcome all the participants who are the teaching faculties from different engineering colleges. And I also take this opportunity to welcome all the honorable speakers who have accepted our invitation to be a part of this particular program. This is indeed a 5-day faculty development program. In fact, to share with you all, we just thought of having a FDP program for 3 days. And later somehow we thought that the 5-day FDP program is really going to be useful for all the faculty members. And then we ventured in finding few more speakers, and with all the support of the department and support of all the speakers, we are able to run this 5-day faculty development program. So this particular program is completely sponsored by the management of Ramaiah Institute of Technology. And the outside, I'm really happy and thankful to all the members of the management and our beloved principal, Professor Naidu sir, for encouraging the department to take up this important faculty development program. As you know, the faculty development program is on the emerging area, advances in highway technology and traffic, which is a very hot subject being chosen for this FDP program. And I'm sure everybody will be appreciating the importance of the FDP. So these days, FDP is becoming a very important platforms, especially for the teachers, mainly to upgrade their knowledge in the emerging areas of research and development. In fact, it's a platform that makes us to know what is really happening as a part of R&D, and also to develop their competency in the relevant areas. And definitely these types of program will give enough confidence for the faculty members so that it helps a lot, especially when they are teaching to the students, and also when they want to identify some important topics as a part of their seminar or as a part of the technical talk, and sometimes to choose an important student's project, maybe for undergraduate students or even for the postgraduate students. I'm very sure that these types of FDP programs are really going to be useful. In fact, we have selected this FTP program in such a way that our faculty should be able to make out what are all the latest developments that are happening, so that they will be able to choose some important topics as a part of their PG dissertation, or even as a part of their research programs. In fact, we have done enough of exercise to select the speakers, and I'm very sure that the deliberations that are going to happen in these 5 days is really going to be useful and beneficial to all my faculty members, and especially the participants who represent different engineering colleges. In fact, the speakers are well-known personalities in the field of civil engineering, and they have a tremendous amount of research exposure, practical exposures. And we have speakers from IITs, speakers from IAC. In fact, we have selected a couple of speakers from research and development organizations, and few from industry. And of course, there are 5 faculty from my department as well. Participants, you know very well that today what is important is the KAS education. This is what I normally endorse whenever I speak to my students. So K stands for knowledge, as you all know. A is the professional attitude. And of course, today what is important is to develop all sorts of professional skills. So keeping these 3 entities in mind, so we have coined today's education as KAS. And in fact, this KAS education, as you all know, is definitely in line with the STEM education or the STEAM education, what many of my colleagues are talking as a part of international educations. So teaching is one important thing. All faculties are very confident. What is available in the textbook is definitely what probably we will speak as a part of the curriculum. But what is that is available as a part of the curriculum? It is more of an engineering knowledge that is there in the textbook. But what is important, my dear participants today, how probably we will be able to transfer the information that is available in the textbook to some sort of a technology. So today, it is the technology transfer that is more important rather than studying about the engineering. So keeping this particular point in mind, and also to know what are all the latest developments that are happening in the technological fields related to transportation engineering, this particular FTP has been formulated. And if you ask me, it is one step ahead than technology. We need to make this particular technology available for the people in an affordable cost. So that is where the technology straight away going to the society is more important. And if that happens, definitely we all will be becoming professionals. Today, what is to be advocated is to inculcate the quality of the professionalism in the minds of our faculty. And with that, if our faculties are able to transfer this concept to the students, I'm very sure all our students will be looking in the direction of seeing some technological problems relevant to their field, rather than simply studying the engineering that is available in the textbook. So with this, I will come to the importance of the today's program. So I definitely need to welcome all the speakers who are a part of this 5-day development, 5-day faculty development program. In fact, today we have with us one of the well-known personality. He is a well-known professional in the civil engineering field, especially in the transportation domain. He is none other than Dr. Satish Chandra, the director, CSIR, CRRI, and who was the former professor of IIT Rourkee. He will be the first speaker. And in fact, we have the other speakers. And in fact, we have Ankit Gupta, associate professor from the Department of Civil Engineering, IIT Bhubaneswar. So we have Rajat Rostigi, professor from Department of Civil Engineering, IIT Rourkee. We have Dr. Ashish Verma, professor from IAC. And we have Arun N.S. He is a principal engineer and well-known consultant. And we have Partha Pratim De. He is an assistant professor from IIT Bhubaneswar. And we have M.N. Srihari, my guru. In fact, we worked together earlier, and we have shared our experiences many times with this particular professional. M.N. Srihari happens to be the earlier faculty of MSRIT. So we also have Gnanendra Kumar, he is the additional commissioner from the Transportation Department, Bangalore Urban Division. And we have Madam Kavita, so she is the associate professor from Rasta. And also we have Dr. Abhijit, so one of the well-known technical person representing the geotextile division. And also I have four my own colleagues who are really doing their research in this particular domain. And myself is another speakers, and I will be the second speaker for the today's function. And I'm sure with these pool of experts whom we have selected from different organizations, I'm really hoping that there will be very good deliberations that are likely to happen amongst the speakers with our faculty members. I'm not going to take much of your time. So at the end, I once again welcome all of you, all the participants who represent different engineering colleges who have logged into this particular program. And also I welcome all my colleagues from the Department of Civil Engineering at MSRIT, and especially a grand welcome to all the speakers who will be a part of this FIT program. So I wish you all the best, and thanks for giving me this wonderful opportunity. Thank you very much.
Thank you, sir. With this introduction to the faculty development program, I would very happily call upon the first speaker, Dr. Satish Chandra. He is the Director of CSIR, a professor from IIT Rourkee, New Delhi. A brief introduction about Dr. Satish Chandra. I request Dr. Satish Chandra sir to switch on his camera so that the participants can connect with you. Welcome, sir. Dr. Satish Chandra graduated from the University of Rourkee in the year 1983 with an honors degree in civil engineering and completed the post-graduation in transportation engineering in 1985. He had his doctorate in the year 1994 from the same university. He joined the University of Rourkee, now IIT Rourkee, as a lecturer in the year 1985 and became professor during May 2006. He was the director, Central Road Research Institute, famously known as CRRI, New Delhi, during 2016 and 22. Professor Satish Chandra has contributed significantly in teaching, research, and consultancy in the area of traffic engineering and bituminous material characterization. He has published around 250 research papers in international and national journals and conference proceedings. Many of these research papers are referred widely in India and abroad. He developed the original concept of dynamic passenger car unit for converting the heterogeneous traffic stream into a homogeneous stream of passenger cars. This concept is well received by various researchers in India and abroad and has been used in several studies relating to highway capacity in India and many other developing countries like Egypt, Vietnam, Cambodia, China, and Thailand. He was the key member of the research team for preparing the maiden edition of the Indian Highway Capacity Manual. He has guided around 21 PhDs and over 100 master's dissertations and has authored 3 books on engineering graphics, air transportation planning, and railway engineering. Dr. Satish Chandra has been the recipient of INSA Visiting Fellowship in the year 1994 and several outstanding research paper awards by the Institution of Engineers and the Indian Roads Congress. He was conferred with Outstanding Teacher Award by IIT Rourkee in the year 2006, and then in 2014, he was also invited by IIT Bhubaneswar as an adjunct faculty in the year 2014. He is the Fellow of National Academy of Sciences, India, famously known as FNASI. He is also the Fellow of the Institute of Engineers, India, and member of several other professional bodies. An outstanding teacher and a highly accomplished researcher, Professor Chandra is very popular among students and transportation engineering fraternity. With this brief introduction, I heartily welcome you and take over. You are requested to take over the talks. I welcome you.
Thank you. I hope you can hear me.
Yes, sir. You're audible.
Fine. Professor and Head, Department of Civil Engineering, MSRRT, coordinator of this faculty development program, Dr. Vivek, and other participants. The topic given to me today is sustainability in highway construction. Let me just put it. Yeah. And this word sustainability has been discussed at several forums at IRC, in the ministry. Its definition basically changes with the field also. If you look at the definition of sustainability, it is the ability to meet our needs without compromising the ability of next generations to meet theirs. That is a very general description of sustainability. That means the resources to be used today while keeping in mind the needs of next generation. And 4 pillars of sustainability are environmental, economic, social, and cultural influences. So anything which basically does not harm the environment, which is economical and fits into social and cultural influences, is sustainable. In road design and construction, it is very difficult to quantify what is truly sustainable. And therefore, the transportation authorities have begun developing manuals and sustainability rating systems that attempt to quantify sustainable design, practices, and elements of transport infrastructure. So in this 1-hour lecture, what basically I would be discussing, what are the sustainable materials, what are the sustainable practices that should be used or being used in highway construction. When we say highways, it is basically low energy consumption, low emissions and air pollutants, and reduced use of virgin material in construction and increased use of recycled material. Now, when you meet out these 3 conditions, then we call them green highways. And in sustainability, if you extend the definition of sustainability after construction also, then it also includes creating safer highways, promotion of sustainable transport system, for example, electric vehicle, which Government of India pushing a lot nowadays, and perpetual payments, which are practically maintenance free. Now, when we say green highways or green technology, so what is a green technology? A green technology is the one that helps reduce emissions, conserves natural resources, reduces waste, and consumes less energy than conventional technology. So if you are able to conserve natural resources, for example, replacement of hard stone aggregate, that's a green technology. If you are able to reduce the emissions, for example, if you can avoid heating of bitumen at site during construction, or lowering down the temperature of the heating, that is green technology. So that will basically, or if you can use waste material in construction, that also becomes green technology. I'll give you a few examples of green technology in subsequent slides. Now, every road construction activity needs thousands of tons of material such as aggregate, concrete, asphalt, and steel. And all these are non-renewable resources. And just to give an idea how much aggregates are being consumed in road construction, 1 kilometer of two-lane asphalt road with aggregate base can require up to 25,000 tons of aggregate rock. And in 2021, India constructed 13,298 kilometers of national highways. Now you can imagine how much aggregate is being consumed in road construction. This 13,298 kilometers is of national highways only. There are state highways, there are programs under PMJSY, there are state government programs also, maintenance of highways also, that will require huge amount of aggregates. And aggregate is non-renewable. Many states have now stopped mining, and now they are finding difficult to get hard stone aggregates. And this is where basically this green technology should be used or comes in picture. Just to give an idea, out of total CO2 emissions, the transport sector has a share of about 13%. And out of this 13%, almost 80% is from road transportation. So when we say green technology, basically our aim is to reduce these emissions, CO2 emissions through transport sector activities. And the construction of an average single lane kilometer of road produces enough pollution, which is equal to 1,200 tons of CO2. Roughly the same amount as the total amount of emissions of 210 passenger cars in 1 year. So you can imagine the size of the problem, the dimension of the problem. And that is why nowadays sustainability is a very buzzword and it is being discussed at several forums. So when you say sustainability or you say green technologies, there are 4 targets to be met. Number 1, to conserve natural resources. And that can be done either making use of thinner pavements or by making use of alternate materials or stabilization of layers. To reduce emissions, we can use core mix technology, warm mix technology, or half warm mix technology. I'll explain all these technologies in my presentation. To reduce waste material, you can reuse the pavement material, that is RAP, and industrial waste, construction and demolition waste, or recycling of pavement, which is also now picking up at very fast speed and consumes less energy. That I told you, cold and warm mixes, or you can reduce mining by making use of local materials, or you can make use of environment-friendly concrete. So these are the targets of sustainability. Conserve natural resources, reduce emissions, reduce waste, and consume less energy. IRC 37 2018 talks about the stabilized pavement. Now, this is also one way of reducing the thickness of pavement. Cement treated subbase and cement treated base. Now, they are being used nowadays at large scale in all national highways, even expressways also, at state level also, stabilized cement treated bases or cement treated sub bases are being used to reduce the thickness of the pavement with same life. Now, for example, if you take, let us say, effective CBR of subgrade soil is 5% and design traffic is 50 MSA. Now, that is the conventional section of the pavement that you need a sub base of 200 millimeter, base of 250 millimeter, and then above that 140 millimeter base binder course, and above that you need 40 millimeter surface course. That comes up to be around 730 millimeter. Now, if you use this cement treated base and sub base, then what you need to provide is cement treated sub base of 200 millimeter as per IRC code, cement treated base of 100 millimeter, that is the minimum thickness requirement, And above that, you provide a crack relief layer of 100 millimeter. And then base binder course will be only 60 millimeter in place of 140 millimeter. And then you provide a BC layer of 40 millimeter. So 730 millimeter thickness will reduce to 500 millimeter thickness. Now that is the kind of saving you get when you use only 2% cement in sub base and 3 to 4% cement in base course. Now when you provide thin pavement, it is not only saving of aggregate, but it is also faster construction. It also results in faster construction. And sometimes it is very critical, particularly in nexalite affected area or where you get a very little window for construction of highways. You need to construct fast roads. And there this stabilization will be a great help. Now, IRC SP 59 talks about geosynthetics materials and their functions. Geosynthetic material can be used as reinforcement, again, to reduce the thickness of the pavement. They can also be used in separation, where you have a very soft subgrade, and you do not want that the aggregate of subbase should penetrate into the subgrade, or subgrade should penetrate into the subbase layer. Then also we can use a geotextile or geosynthetic material. It can also be used for filtration and drainage purpose. It is being used in erosion control to protect these landslides, or it can be used as moisture barrier also. There are several advantages of using geosynthetics. One is pavement stabilization. As I told you, when you reinforce a layer, you reduce the thickness requirement in comparison to conventional pavements, and therefore you save the cost also, and you save the time of construction also. And geosynthetics are easy to handle and lay at site, and therefore it's a faster construction and low CO2 footprints. These are some of the photographs I have taken from IRC SP 59 2019 of different types of geosynthetic materials which are used in highways: geocells, geogrid, geonet, geotextile, and geomet. There are many more. Even you have different types of geotextiles also which are being used. Now geocell is now coming up very fast, and people are realizing the advantages of using geocell in concrete as well as in flexible pavement. And this is another example where you have a subgrade CBR of 5%, and it is a design traffic is 30 MSA. You design a pavement. Conventional design will require 40 millimeter of BC, 150 millimeter of DPM, 250 millimeter of WMM, and 200 millimeter of sub-base material. When you use geocell, at sub-base level, then you need 200 millimeter sub-base with geocell. Above that, you provide 250 millimeter WM, same, but DBM layer can be reduced from 115 millimeter to 75 millimeter. Now, why we are reducing basically DBM? It is because this is the layer which is most expensive in comparison to WMM and sub-base, and 40 millimeter BC. So when you use geocell in sub-base layer, you can reduce this DBM thickness by almost 35%. And a question is always raised, a question is always asked, what is the economy? And just for the information of the participants here, I would say that geocell cost is around 200 to 250 per meter square, whereas cost of laying 50 millimeter DBM is 500 to 550 rupees per meter square. So it is not expensive to use geocells. It is economical also. It will give lesser thickness of the pavement. It will provide faster construction of the road. Now this is one test trial section which is being laid nowadays in Himachal Pradesh using geocell, and this is the road owned by BRO near Manali Sarchu Road. That is a test section taken for demonstration of use of geocell in flexible payment. And another section which is being laid, I think this has been laid very recently in Arunachal Pradesh, which is with GeoGrid. Now, this is also, you can see the role here, you can spread, you can lay this very easily, doesn't require any skilled manpower. And above that, you provide the layer of base course. This layer can be, I mean, reinforcement can be at any stage. It can be between base and sub base. It can be between base and bituminous course also. Now, after these sections are laid, they will be monitored for 3 years for their performance, and then report will be sent to IRC for improvement in the IRC course. That is how basically courses are framed. Another important point which I would like to discuss with you is payment recycling. Now, this is also coming up in a very fast way nowadays, and people are recommending payment recycling. What is recycling? Recycling basically is the reuse of payment material after some processing. So what happens that when a road has failed, then you use the top material or maybe top 2-layer material to reconstruct the same road. This process can be either cold or it can be hot. And in cold also, it can be either in plant or it can be in situ. And therefore, the payment material recycling can be classified into 4 groups. That is, payment recycling can be cold or hot, and cold can be in plant cold or in place cold, and hot can be in plant hot recycling and in place hot recycling. All the four methods are in use. Say this example. Let us say you have a road section where cracks have developed, very deep cracks have developed, and they have penetrated up to the level of subbase. Now, one option is that you excavate this material, complete material, and reconstruct the highway. It will naturally be very expensive. It will require long construction time, and you need to accommodate traffic for a longer period, which is also sometimes very difficult because you do not have alternate route available. So during construction, you may have to provide diversion routes. Another option could be that above this cracked surface, you provide a thick asphalt overlay. First, you provide a layer of, let us say, DBM or maybe WBM, not WBM, sorry, WMM, and then you provide a thick overlay. Now, this is relatively a quick method, but the problem will be of elevation. And it is very particular, a very important consideration when you are basically working in urban roads. In many cities, what we have seen that when you provide overlay after overlay every 3 years or 4 years, the pavement elevation goes up. And that creates a problem of drainage. Now, this will also have the problem of reflection cracking. Now, that's a very typical problem, or you can say typical characteristics of flexible pavement, that if these cracks are not treated properly at the time of overlay, then they will reflect the surface in no time. That is called the reflection cracking. The third option could be that you recycle the material of this pavement, you basically excavate this material, add some virgin material, depending upon the requirement, depending upon the grade of the material, and then above that, you provide a very thin overlay. This is very price effective, environmental friendly, and a quick method. This is what is being adopted nowadays. In many projects of national highways where the road has prematurely failed, recycling is being adopted because that will not require aggregate to be transported from long distances. And therefore, you can have in situ recycling, cold recycling, or you can have in-plant recycling. In-place recycling or in-situ recycling is opted where material from the upper layers of an existing pavement is to be recycled. And this treatment is popular due to less material haulage. I told you, you don't have to transport the material either to the plant or from plant to the site. And this processing is normally opted where recycled material is used in new pavement layer. That is for, the in-plant processing is normally opted where recycled material is used in new pavement layers. So what basically I'm trying to say here is that in case of in-plant recycling, the excavated material from the site is stored here in the form of stockpiles, and then this material is used in some other strengthening purposes. Now let us take one case study. This is the highway. I would not basically name the highway, but this is a national highway which prematurely failed. And you can see the amount of rut and the type of cracking here. And it failed because of several reasons. It was investigated in CRRI, and then then the deformation, depression, settlement, everything was there. And then we studied the two options. The first option was that you go by conventional methods, that you provide an overlay of granular subbase. It is basically almost reconstruction of the highway. And then dense bituminous macadam of 185 millimeter. And above that, you provide a layer of 50 millimeter bituminous concrete. The second option could be that you recycle the pavement. And therefore, cold in situ recycling using form bitumen approach was considered. Now, when I say form bitumen, it is basically when you use the material, in base course, then it is called bituminous sub base course, or you can say bitumen stabilized base course. So here bitumen is formed, and the green effect of this, if you compare the conventional overlay where you are providing so much of thickness, 450 plus 185 plus 50 millimeter, and in case of cold in place recycling, you provide GSB of 450 millimeter, and this material is bitumen stabilized material, BSM of 175 millimeter. Now this is the material which is excavated from the site. Same material is used with some virgin aggregate depending upon the grading required and grading available, with some rejuvenator. You use the same material and compact it there in the layer of 175 millimeter. And above that, you provide a DBM layer of 70 millimeter and then 40 millimeter. So this is what basically done. And by forming technique, you can use up to 80% of recycled aggregate. That will require 60% less bitumen, because bitumen is already present in the top layer. So that bitumen can only be rejuvenated. You can use that bitumen. And there are methods of designing the mix for cold in place recycling and hot in place recycling. Now, hot in place recycling, in this case, the surface is heated by infrared radiation, and then it is milled in 2 steps to a desired depth of 20 to 65 millimeter. The mix of the old asphalt layer can be changed directly by adding virgin asphalt and new type of bitumen, or sometimes you need to add some rejuvenator also. And because this bitumen, which is available in the layer, becomes very hard because of aging, and sometimes adding virgin asphalt is not sufficient, and you may have to add some rejuvenator to bring the viscosity down. And I also have my YouTube channel with this name, Satish Chandra IITR, where I have discussed, in one of the videos, I have discussed how to design a mix for hot in place recycling. If you are interested, you can just watch that. Now, the requirement of hot in place recycling, that layers below the recycling must be intact. That is, the failure should be restricted to the top layer. And material in recycling layer must be suitable. Application possible for all asphalt layers, including asphalt layers with polymer modified bitumen. Now, this is something many times it is doubted whether if a layer has been laid with polymer modified binder, can it be recycled? The answer is yes. Any bituminous layer, whether it is polymer modified bitumen or natural rubber modified bitumen or VG40, provided the layer below the recycling layer is intact, it can be recycled. Applications of hot in place recycling can be several. It can be used to treat raveling in the bituminous layer or bleeding, corrugations, shoving, slippage. These are all pavement distresses. And I hope you all know these distresses. I am not going to discuss all this because this is not the scope of the presentation today. And hot in place recycling is suitable for surface course rehabilitation with a maximum working depth of 60 millimeter. So in this process, what is done, that top layer is heated through infrared rays, and this is then excavated. The top layer of 60 millimeter depth is excavated. It is transported to the next machine at the site itself, where it is tested for grading and binder of the viscosity, and the deficient materials are added into it. And then after it is mixed with the new material and the old material, it is compacted there itself. Another important consideration in sustainability is use of waste materials. And there are several types of waste materials which are available nowadays in the industries. And industries are facing a lot of difficulties in disposing of all these materials. And therefore, we should always try to see whether these waste materials can be used in roads, and if yes, in which layer and in what quantity. Now, I have listed here few. Fly ash, you all know, iron and steel slag coming from steel industry, and steel industries are facing a lot of problem. Ministry of Steel is also concerned about it, and looking after the solution for disposing of this slag. Copper slag, construction demolition waste is another problem in every city. Foundry sand, although its quantity is not very high, but it can also be used in sub-base as replacement of fine material. Now, municipal solid waste is a problem in almost every city. Overburnt brick bats, and I can tell you here that our northeast region is severely has severe problem of non-availability of hard stone aggregates. And they are transporting these aggregates from a very, very long distance. Andaman and Nicobar area, for example, they are transporting from the mainland. So is it possible to use this overburnt brick bats in sub-base or base course by proper treatment of this material? Not exactly, not as it is. By making use of lime or making use of some cement, can we use these materials? And this was done in the state of Tripura about 6-7 years back, maybe 8 years back. When the road was constructing and they could not find any good material there in Tripura. So they used the clay to make the bricks, and then bricks were broken into bats, and then some 2-3% cement was mixed with these brick bats to make the same sub-base of the road. And there are many more waste materials available in the country, but these are the main materials which have been studied extensively, not only in India, but other countries also. And I'll give you some view of these materials, how they have been used. For example, fly ash. It is being produced in huge quantity, about 200 million tons per annum. And its utilization is only 60 to 70%. In the concrete, in making bricks, in making cement, in making road embankment in agriculture. The thermal power plant stations are facing this problem of disposal of fly ash. And there can be several applications. It has been researched for last 40, 50 years. Laboratory studies have been conducted extensively on use of fly ash in different layers of a pavement, and results are encouraging. Only point is that it has not been used in field for a very long time. But now the people have realized, now IRC codes are also available, and even our field engineers are realizing that fly ash is a good material, it should be used. Because when you use fly ash in construction of embankment, you make its bulk use. It can be used as a backfill of retaining wall or reinforced earth walls. It can be used as a stabilized fly ash in subgrade or sub-base and base course of a road pavement. In fact, there was a project sponsored by Department of Science and Technology very recently when I was in CRRI, we worked on this project, how to make use of fly ash in sub-base and base course of a road pavement. It can be by stabilization through lime, which you call lime fly ash concrete. It can be used in dry lean concrete, or it can also be used in roller compacted fly ash concrete. It can also be used as replacement of cement in concrete when it is in wearing course. So there are several examples in the field now. For one example, which basically I always give, that how the bulk use of fly ash was made in approach embankment for second Nizamuddin Bridge at Delhi. It was in 1998. The length of this embankment was 1.8 kilometer. Height was 6 to 9 meters. It was on River Yamuna. And this was the design which was used in the cross-section of the approach embankment. And because the pond ash or fly ash is a very soft material, compaction is always a problem. And therefore, it was used in layers. First, you have a layer of 2 meters of ash. And above that, you have 40 centimeter layer of normal soil. And then again, you have a 2 meter thick layer of ash. That is how it was designed. And 1.5 lakh cubic meter of fly ash was used in this. And that was a saving of 1 crore because you are replacing natural soil. Now, this saving basically 1 crore in 1998. Now, this saving is only what you basically see in monetary terms. But imagine the saving to natural resources. When you are basically take the natural soil to make the embankment, how much damage you cause to the environment. So it is basically replacement of soil by ash. It is working very well even today. If you have traveled to Delhi, the first bridge you will cross after entering Delhi from UP side will be this bridge. Another example is where this reinforced fly ash was used for flyover approach embankment. Now, this is how the reinforcement was done. The length of this approach road was 90 meter and maximum height was 5.2 meter. It was in 2001. And this polymeric friction ties were used for reinforcement. And this is how this embankment was made and open to traffic in 2001. It's also in Delhi. And the amount of ash utilized was 35,000 cubic meter. So when you use the fly ash in road construction, when you use in sub-base, for example, you can make bulk use of material. Now, utilization of fly ash in sub-base and base layers of road pavement. It can be, as I told you, it can be cement stabilized fly ash and can be used either in base or sub-base. We have demonstrated it. It can be stabilized with lime also and can be used in base course or dry lean cement fly ash concrete as base course or even roller compacted concrete in wearing course. And precast block paving, or you can say precast paving blocks, are nowadays being made using fly ash, which can be used for for pedestrian walkway, for parking, and similar other uses. Another waste material which is coming from the industry is copper slag. Its production is 2 million ton per annum in the country, and the present rate of utilization is only 10 to 20%, and that is particularly for landfilling. And these are huge mountains in the industry which are basically building up. So this was also studied in laboratory, and this can also be used similar to fly ash. This can also be used in road embankment. And this was the cross-section of embankment which are designed for Madurai Tuticorin section of NH45B, and it was implemented. Now here, 50% copper slag and 50% pond ash was used. Both materials are waste materials. And again, you see the 2-meter layer of this material and then 20 centimeter material of natural soil. That is basically sandwiching the layer of waste material between the layer of soils. This was constructed on NH45B. That is the first stage of mixing of copper slag with soil or copper slag with fly ash. Both options were basically proposed and used to compare the results. And this is after compaction of copper slag plus soil mixture. And this is the compaction of copper slag and fly ash in 50-50%, and that is the finished surface of the embankment, of the layer, not the embankment, layer. And this was open to traffic. It is going very well. It was monitored for 3 years, and this is on Madurai Tuticorin section of NH45B. So these materials are now being used because when you use them in the field, you have the confidence. The engineers will have confidence, and that is how IRC codes are made. You see, the basic problem in road industry is that this is my experience of last 6 years in CRRI when I had discussion with either ministry or in IRC. The basic issue is that any new material cannot be used in field unless it becomes part of specifications. And the material will not become part of specification unless you demonstrate that it will perform well in the field. So that is the kind of vicious circle you always get. And therefore, what should be done and what strategy is being done nowadays is that we take some trial sections on national highway or state highway to demonstrate a technology or a material, and then monitor it for 3-4 years, and then approach IRC that look here, this is the report, and now you have to make the code. This section also its performance was observed for 2-3 years, and it was fantastic, as good as normal section. Because probably you know that the stress is developed in a pavement section. Very little stress goes to embankment layer. So embankment layer material, provided satisfies certain conditions of cohesion and density, it can be used. Another waste material which is available now is phosphogypsum. And this was also demonstrated in field where embankment was made. There again 2 types of trials were made. In one trial, the phosphogypsum embankment was made, and then above that subgrade soil was used of 500 millimeter. Now here the embankment was made of soil and subgrade was made of phosphogypsum, and both these sections were constructed in the field. That was the original ground laying of phosphogypsum, compaction, and then feed evaluation by DCP, that is dynamic cone penetrometer test. And above that, the normal payment was laid and the finished road. Now, this is another problem of every city, whether a small city or big city, municipal solid waste. It's just a photograph of one site in Delhi where huge mountains of this municipal solid waste is piled up. And the government of Delhi and government of India both are worried about how to make use of this municipal solid waste, because it is not only environmental hazardous, but it is safety problem also, environmental problem also. And we took up this challenge in 2016 when I joined CRI. Immediately after my joining, we tied up with NHI, start working on how to make use of this municipal solid waste in road embankment construction. And we submitted this report to NHI, although it could not be taken to field because of several reasons. And I'll tell you one reason why it could not be implemented yet, even after 6 years. And we also proposed design of cross-section for field construction. And we studied environmental feasibility also. And what we found that almost 65% of this material can be used in the embankment. The challenge here is because this material is very heterogeneous. It contains plastic, it contains wood, it contains metal also, it contains C&D waste also. So many things. And it has almost 30% moisture. So it should be dried, it should be segregated, and then it can be used. Now, this is where the East Delhi Municipal Corporation or South Delhi Municipal Corporation are hesitant, because this drying and segregation of this material will require huge cost. And what basically I was trying to convince the authorities here when I was in CRI, that don't look at the cost of segregation and drying. Look at the cost of environment, cost of the land. We are basically vacating 80 acres of land, prime land in Delhi. But you know the government system, how it works. Now, this is the kind of material. After you segregate, this is what we done in the laboratory. We devised a methodology to segregate this material. This is passing 80 millimeter. This is passing 35 millimeter, passing 16 millimeter, and passing 4 millimeter sieve. And after that, this is what can be used. It is a mixture of soil and aggregate, and almost 65 to 75% of the total material can be used. And we can remove the plastic separately, and those plastics can also be used in the top layer. Now, steel slag coming out of steel industries. Now, using steel slag also, CRI constructed a test track on this Dima to Mango in Jamshedpur using steel slag aggregate, and performance was evaluated and it was fine. Similarly, another section was made from Ranchi to Jamshedpur on NS33 using steel slag. And important point is that steel slag is very heavy, and therefore requirement of bitumen is also low. It can be used in base course, it can be used in sub-base course, it can be used in bituminous course also. The only problem when you use in bituminous course is that these aggregates have vesicular structure, and therefore they can absorb bitumen, and this bitumen can ooze out during hot summer, creating the problem of bleeding. And therefore the industries are now working to how to make this steel slag which is not vesicular in their surface. So they are treating methodologies to be changed so that this aggregate can be used in top layer also. Otherwise, it is very suitable for lower layers. Ferrogram slag is another important waste which is available, and it is as good as natural aggregate. air-cooled, water-granulated ferrochrome slag can be used in place of natural aggregates. And lab studies have indicated that it is as good as natural aggregate when used in the bituminous layer also. Resident modulus at different temperature and moisture susceptibility and rutting tests have been conducted. Just a moment. पारुल मैं भी मीटिंग में हूँ 5 मिनट में बात करता हूँ. Now this is the kind of slag 40 millimeter, 20 millimeter, 10 millimeter. Very heavy. And finding of this laboratory study indicated that they are hard, angular, and rough, and therefore they provide better interlocking. And this slag-based GSB can be adopted in roadworks in case where adverse drainage conditions are not present, because water absorption is high in these aggregates. I still have 10 minutes. Yeah. And comparable results were obtained from ferrochrome slag for bituminous concrete in terms of rutting, strength, and Resident modulus value. Now, waste plastic is another problem. You know it. And there are two methods of using waste plastic in roads. One is called wet process, another is called dry process. In wet process, this material is mixed with bitumen, and in dry process, it is mixed with aggregate. Now, dry process is more successful than wet process, because in wet process, there is always a problem of miscibility, or you can say compatibility. And in dry process, this shredded plastic is heated with aggregate at 150 to 160 degrees centigrade, and then mixed with bitumen. Normal process of mixing, no additional equipment are required, and we can use by 6 to 8% plastic by weight of bitumen. It has been demonstrated in several projects in Delhi, in Himachal Pradesh, Arunachal Pradesh, in Haryana also, and it is successful. And now IRC guidelines are also available on this material. This is one test section which was laid using waste plastic in Delhi in 2012. Now, when you say reducing the energy, there are emulsion-based cold mist construction, which we call the cold mist technology also. And this technology, in a normal hot mix asphalt, we heat the bitumen and aggregate at a temperature of 160 to 170 degrees centigrade and then mix them. And that will naturally require a huge amount of energy. Where in case of cold mix, we don't need to heat either aggregate or bitumen. It can be done at ambient temperature, and therefore it is environmental friendly, less energy consuming, low carbon footprint, high production output, and so on. And almost 10,000 kilometers of the roads have been constructed under PMJSY using this cold mist technology. Now, at present, this cold mist technology is used only for premixed carpet. It has not been developed for high volume roads, but people are working on this technology for national highways also. This is the glimpse of Rajasthan. Microsurfacing is another which is given IRC SP81. This is also cold mist technology, and it has also been laid on several roads in Delhi. The only issue here is that it is not a structural layer, and therefore now this is just a mixture of polymer modified emulsion bitumen, dense graded crushed mineral aggregate, filler, water, and some additive. Its thickness is about 8 to 10 millimeter only, 8 to 10 millimeter, and therefore it's not a structural layer. And advantage, there are several advantages, but I would list here only 3: fast construction, cost effective, and no rolling is required because you are using additive. So it's a fast setting. The limitation is that the temperature should not be below 10 degrees centigrade, and it is applicable when pavement and air temperature are above 8 degrees centigrade and it is rising. It is not applicable when the finished product freezes within 24 hours. The basic conditions, the pavement should be structurally sound, because I told you it is not a structural layer, it is only to improve the riding quality. Small undulations can be treated. Wide alligator cracks, transverse cracks should be repaired prior to application of microsurfacing, and all deep ruts in excess of 8 millimeters shall be filled up before application of microsurfacing, because that is the thickness of the layer, 8 millimeter to 10 millimeter. And therefore, any rut in the pavement, which is beyond this, should be filled up before application of microsurfacing. And as I told you, we have almost laid this microsurfacing on 30-kilometer length in Delhi, and performance of these sections was monitored for 3 years. It is a very good construction. Now, something between hot mix and cold mix is warm mix. In warm mix, the production temperature is in the range of 120 to 135. In place of 150 to 160 degrees centigrade, the production temperature is 120 to 135. And there is another technology which is called half warm mix. And there we can produce the mix even at temperature below the boiling temperature of the water. That is 80 to 100 degrees centigrade. Now, these are the emerging technologies which allow the mixing, laying down, and compaction of the bituminous mix at lower temperature compared to hot mix. And you can see the emissions here. Now, this is a hot mix plant and this is a warm mix plant. Now, here what is done? Some additives are used. Some additives are added to the bitumen which bring down the viscosity of the binder, and it is easy to coat the aggregate at lower temperature. And these are the lab study result. That when you compare HMA mixes with warm mix mixes, the emissions, the fuel requirement, the CO2, CO, SO2, everything reduced. And evotherm basically is an additive which is commercially available in the market to be used. And very small amount, sometimes 0.5% of by weight of bitumen. And this is one section on S27 in Gujarat, which was laid in March 2012, half warm mix binder and with bituminous concrete. But half warm mix is not so popular as warm mix. Now, yeah, another one is green concrete. I'm about to finish now, Vivek, maybe another 2 minutes. Now, green concrete is a type of concrete which is much like the conventional concrete, but the production of such concrete requires minimum amount of energy and causes least harm to the environment. Again, I will go by definition of the green material. This is based on the definition of green material. A concrete made with waste and that uses less energy in production and produces less carbon dioxide than a normal concrete. And materials for green concrete can be recycled demolition waste aggregate. It can be recycled concrete aggregate. It can be blast furnace slag or manufactured sand, glass aggregate or fly ash. And here's some of the materials which are used in making green concrete. These are the fresh local aggregate, recycled demolition waste aggregate, blast furnace slag, recycled concrete material, or manufactured sand for concrete. Blast furnace slag is available in the form of sand also. And we can also use fly ash. And major applications of green concrete, it is being used now in construction of bridges also. So you can make a very high strength concrete using these materials. It is being widely used in building construction, in construction of columns, and can also be used in road construction, although it has not been tried in roads. Thank you very much for your patient listening. If you have any question, I'll try to answer that.
Hello.
Yeah.
Am I audible?
Yes.
Yes. I would like to go for a forum discussion after this talk. So I would like to know if anyone wants to share their opinion or have any kind of questions so that sir could help you with that. Please be brief. Hello.
Yes.
Yeah.
I think this was a general presentation, maybe no question.
Sir, one question is that I read out. The question is, can we directly use fraction of MSW passing 4 mm steel instead of incinerated MSW?
No, Vivek, I couldn't hear your question. What is the question? Just a moment. Let me just put. What is the question? No. Sorry. Just a moment.
Are you audible?
Ah,
Am I audible?
yes.
Okay. So the question is, can we directly use the fraction of MSW passing 4 mm steel instead of incinerated MSW fly ash? This is by Dhruv Trivedi.
MSW is municipal solid waste.
Yes, sir. Please go ahead.
MSW is municipal solid waste, and fly ash is another type of waste material. It's not good to compare these two, but if you are using an amendment, both materials can be used. Fly ash can be used in sub-base also by stabilizing, and even in base course also. But MSW cannot be used in base course and sub-base because their performance has not been studied so far.
Mr. Dhruv Trivedi, I hope this has answered your query. Sir, we have one more
Does
question.
it answer your question, please?
Yes, sir.
Okay.
We have one more query, sir. Mr. Deeptikanta Roth. The question is, can we use the crumb rubber powder, CRP, in rigid pavement construction as waste material? Is there any codal provision regarding the CRP? That is the question from Deeptikanta Roth.
There is no codal provision for this because the major issue with crumb rubber is that it swells. When it comes in contact with the water, it will swell. It has some people are trying to use it in concrete as a fine material, replacement of fine aggregate. But the results are not very encouraging, and truly speaking, I am not very aware of any construction being done using this crumb rubber as fine material in concrete.
Mr. Deeptikant Raut, is that the answer for your question, or you have anything to ask? Anyone else? Yeah. So we have one more question. Mr. Bijendra Kumar Singh. The question is it goes like this. Can we use the
problem
sulfur?
of sulfur? I read this question.
Yeah. Okay.
The problem with the sulfur is that it is environmentally not a friendly material when you heat it above 80 degrees centigrade. And that is how basically sulfur modified binder has failed. If you remember, Mr. Bijendra, Shell Bitumen India brought one modified binder which was sulfur based. It could not be successful because when you heat bitumen above 80 degrees centigrade, the fumes are coming out. And these fumes become very hazardous, or you can say health problem to the workers at the plant. So sulfur is good as long as you do not heat it above 80-85 degrees centigrade. Yeah, Amardeep.
Yeah. So we have one more question from Mr. Amardeep. Can we use the plastic aggregate in rigid pavement? And if yes,
you have to. Yes, yeah. Plastic aggregate we have not used yet, but plastic is being used, or you can say is being tried to make tiles. Plastic is being used to make tiles, particularly for walkway. And now one scientist in CRI is working on plastic panels also. So plastic, basically you have to set up an industry to make aggregate out of the plastic.
I hope it answered your query, Mr. Amardeep. Sir, we have one more question. Is there any quality check of plastic used payments with bitumen payments? What would be the durability of such payments under different seasons? This is by LG Santosh. Ramaiah College?
Unfortunately, my answer is no, because even in the roads which we have used this plastic, we cannot have a quality check whether plastic has been used or not. And this is what NRD is also facing the problem. And they are also looking for a test that can be used to find out the amount of plastic which has been used, actually used in the road. You might have read in the newspaper that there was some problem in Bangalore city where they bought some plastic and they did not use it in the road. And but they still called that they have made road with the plastic. So that is still under research, how to determine the amount of plastic that has been used. Now, as regards to the performance of these plastic roads, they have been very well researched and implemented in field, and they are, I would not say as good, even more good than a normal road, because this plastic provides more stiffness to the pavement. So it is without compromising on quality of any layer, any material, these roads are as durable as a normal road.
Okay. I think that answered your query, Santosh.
Wrap material, yeah, Ravish, wrap material in rigid pavement is being used, but only at lab level. It has not been, but if you take construction demolition waste, if you are basically, if you want to reuse the material which is coming out of the uh, concrete slab, that can be used in the lower layer in dry-in concrete, even in paving quality concrete also.
Thank you for the query, sir. We have one more question by Mr. Mohan. He wants to know if recycled asphalt pavement is used in sub-base layer, and can it satisfy the drainage characteristics? And if it does, should it serve the purpose? This is by Mr. Mohan.
That you have to see, grading has to be met. When you use any material for sub-base material, when you use any material in the sub-base, the grading should be met. Otherwise, it will not drain well, because that is the main purpose of sub-base material. So it depends upon what material is being used. If you are recycling the base material, that probably can be used in sub-base material.
Okay. So we have the last question for today. We are running short of time, by Ms. Nagashri B from our own civil department. Can we use plastic additive as a layer-based additive instead of using it as a whole product?
I couldn't follow. I could not follow the question. Can you ask the participant to,
Yeah. What would be the optimum content of the plastic used as an additive? That is the question, sir.
Optimum content, I told you, 6 to 8% by weight of bitumen.
Okay.
6 to 8% by weight of bitumen is used, because if you use higher percentage, the mix will be very stiff. It will crack.
Okay, sir. I thank all the participants for their interest and queries shown. Sir, I think we are running short of time, and any other information, the participants can directly contact the speaker.
Sure, you can contact me. And yes, I told you I have a YouTube channel also. You can watch the videos there. You will have more information.
Yes.
Thank you.
Thank you. We really appreciate the time you took for us for the program, sir. I'm really grateful for your talk and also for your thoughts and experiences you have shared with us. We as the coordinators and the Department of Civil Engineering, Ramaiah Technology as a whole, would like to thank you for the informative talk. It was a wonderful opportunity to see such a big personality like you, for having been with us as the foremost speaker for the faculty development program. We all agree that your speech was an interesting one. It was truly a memorable morning, and we hope such talks and discussions do come often. Thank you for accepting our invitation for this program and sharing your expertise with us. Your experience and ideas are fascinating.
Thank you, my pleasure.
It was an inspiration as well as our privilege that you were a speaker for the program. And it seems that everyone wants me to express the appreciation for your inspiring presentation. Please accept our profound thanks once again for taking out the time from your busy schedule and enlightening us. Thank you so much.
Thank you.
Yeah. Yeah, before I end, thank you, sir. Before I end this session, we have our beloved head of the department, Dr. I. Venugopal, who was really busy with the management in the morning. And in spite of he being busy in a meeting, he gave a green signal to go ahead for the program to start on time. Venugopal sir wants to address the program. So I seek his presence. I welcome you, sir.
Good morning to all of you. At the outset, I'm definitely sorry that I could not come on time. So, but still, I would like to share some of my feelings. Formally, I invite every one of the participants, offline and online, for this wonderful program, which our colleagues in the Department of Civil Engineering at Ramaiah Institute of Technology, Bangalore, have organized this 5 days faculty development program with the title of Advances in Highway Technology and Traffic Systems. And just to say a few words about this prestigious institution where I am heading as the head of the department. So the Ramaiah Institute was actually got award in 1971. Almost 5 decades of the service has been put to the society, and it has got its own niche and a position in academics, research, consultancy, collaborative works, and also a large number of the technical publications by my esteemed colleagues. And got accreditation by NBA since 2001 and got reaccredited up to 2024. So more than 25 research works are going on as of now, and a lot more MSc programs also happen. So it's credit to the institution and to the Department of Civil Engineering, more than 250 highly valued the technical publications have appeared and many more on the way. And of course, it also got a credit of patenting a few important innovations like total replacement of sand in concrete by pond ash. It has been patented by the Institute. Of course, it is actively involved in academics with the cooperation and active participation of the people like all of you, and has been continuously on the pursuits of conducting the FDPs, that is basically faculty development programs, site visits, project tours, academic collaborations. I would like to take opportunity with this background. This kind of a programs, when executed, will make a bigger platform for all of us among the academia, industry, research, and developmental projects and institutions and the government bodies and also actual users, government officials. Let's make this particular kind of a one-to-one interaction be a base so that further our future collaboration efforts will be much more intensified to yield the good results for the benefit of the society and academics in particular. As you know, the government of India, when it has started the Golden Quadrangle program, it has really changed the whole scenario in India, how the auto industry developed, how the roads have developed, how the overall progress has developed. Everybody is a witness to that. And similarly, many more programs have been also taken by the government of India. And it's very nice to know that there is a plan of constructing 65,000 kilometers of the highway in the 5 years, and at the cost of 5.35 lakh crores. So this is a good information to all the professions, more so the budding engineers and the student community, what kind of scopes are available in the highway engineering to make a good career. The money earmarked is as much as 5.35 lakh crores of rupees. So that's an indication. And also it's very nice to know that almost like a 14,000, almost 13,300 kilometers we have constructed in 1 year itself, that too being under the pandemic situation. So this is another indicator to say that how the people are committed to the work, irrespective of the real environmental and health conditions. That's kind of the commitment that India and Indian people have got it. So a long way to go to achieve more and more milestones. Now, I would like to share one or two things. We have been seeing a large number of the articles, publications, research works, especially which deals with how we can use commonly disposed of what we call the waste material or unused materials, essentially from the industry waste, how they can be used either for the concrete or what we call a replacement of the concretes or for the highway engineering. A lot more articles have been appearing since almost 3 to 4 decades. It is very nice to see that a lot more academicians, a lot more researchers, a lot of government bodies are putting a lot of soul and mind into the work and coming out with the wonderful inventions. and being found to be in applications and also in implementation. But perhaps here I would like to say, essentially, when you use any kind of the substitute material as a replacement, we need to have a thorough kind of a studies, how the proposed material gels with the rest of the materials, the one aspect studied in greater detail over a period of time. Second thing is how that material in solo behaves under the dynamic loads or the repetitive loads or under the fatigue, and how it exactly under the dynamic load, it changes its behavior. Apart from intergranular behavior, particle behavior, how it deals with other material, the composite material, how it behaves. Maybe there are 3-4 materials put together, we make a total cross section of the road, not more than 2.5 feet, that's 600, 750. But every material has got its own role to play. Perhaps a lot more research is required, because in our practice, when we use the new materials, though we anticipate for a good results, most of the times it does not happen for various reasons. So a large building material study in detail under the fatigue over a period of time, extensive work need to be done. That's how I would like to share as an industry man, because I have come from ISRO to this prestigious organization, what kind of problems we had in laying a lot of roads and different roads under the war footing conditions. We have been exposed to that. So therefore, I would like to share. So that kind of a research work in collaboration with the famous, competent academic institutions and research bodies will make a big way for the development of the country. And as for the present program is concerned, it's very nice to know that we have the 15 esteemed speakers. I was keenly listening to the first speaker, Dr. Satish Chandra. Really very thanks a lot, sir, to your good self. You have extensively covered various topics, and it's very nice to have a person of your stature on our board as one of the speakers. And essentially the first speaker, you really put a good milestone, your trend, you have a nice trend you have put in that. You have covered various aspects, and you have really added your experience as an academician, researcher, and a scholar, and a practicing engineer, and a consultant. All in all, the essence has really percolated down to all the participants who have been getting benefited out of this novel program. So with this, a few words, I once again request that let this 5 days interaction become very fruitful and interpersonal and intercommunicative. Let this be beginning of our larger association in the days to come. Ramaiah Institute looks forward to see that we can have a large number of collaborations, made to be consultancy or made to be academic collaboration or made to be a giant ventures. We have a strong faculty with us and dedicated. We would like to have a lot of combination and coordination with all of you and make a good team, and we'll be able to contribute in this wonderful, evolving, and very advanced and very interesting field. With these few words, I take a leave of you, sir. Thank you very much. All the best.
Thank you, Dr. Venugopal. It was really a pleasure having you, in spite of your busy schedule in the morning. It was really a pleasure having you, and for your interest shown to the FDP and briefing us and giving a feedback for the talk. We hope all of us had a good morning, and we would be coming to the end of this first session. We can go to the next speaker. Yes, we would be meeting at 11:30 for the next speaker, Sri MC Nataraj.